What they're doing.
All right, guys, page 5.
You guys been eating.
But even like I see you in the hallway, you do it as well.
I look at people, if I do it subconscious.
Oh. So basically, that's done.
Okay, so a lot of what we're gonna do today will feel very familiar. So we just have to kind of get used to polar graphs. But at the top of the page here, just as a reminder, we know that we can get to a point on a graph from a rectangular perspective. I can go left X units, go up Y units, and I'll hit, I can hit any point on the graph by identifying the horizontal and vertical components. But I can also reach that same point using the angle and the radius. So just like the last unit, we have to be comfortable being able to go from rectangular form to polar form. Polar form just means getting information from a radius and theta perspective. And we learned this last semester, right? To get from r and theta to x and y, we can use sine and cosine. To get from x, y to r and theta, we can use distance formula and inverse tangent. Okay, so if we know r and theta, how do you calculate x and y? We know cosine of theta is equal to x over r. So therefore, x equals r cosine theta. Okay, and since we know that sine of theta is opposite over hypotenuse, let's multiply. I'm sorry, y over r. I got it mixed up. Sine of theta is opposite over hypotenuse. Let's multiply. It keeps y over. Let's multiply. Hey, likewise, if we are starting with x and y, how do we get to r and theta? We know that r squared is x squared plus y squared, the Pythagorean theorem. So square root of x squared plus y squared. We know the relationship between theta and x and y is tangent. Tangent of theta is b over a, or we can say y over x. And theta is the inverse tangent. Okay, so here we're given the polar coordinates, and we want to convert our r and theta to be in terms of x and y. So we know that if we're given r and theta, we're going to use sine and cosine to get to x and y. So first number is your r, second number is your theta. The calculator can handle negative degrees, but you can also add 360 to make it more familiar if you like. Either way works. So if I want to find x and y value, you can just as easily put 4 cosine 300 degrees. Make sure your degree mode.
So we're able to convert r theta into x and y. But they will both get to the same location. So let me just show you here. If I want to go 4 units along the 300-degree line, that's fine. Like negative 3.46. So this is my 300-degree line here. The 45 degrees not showing, it's only showing the 30 and the 60-degree reference angles. So if I go 4 units down, but I can also go to the left or to the right and down and still reach the same point. All right, so I go 2 units and down 3.46. Yeah. So we can arrive at the same point, either in polar or rectangular form. It will take you to the same location. They're just getting to the location using a different set of information. Okay, try number 2. We do want to make sure we're in what mode though? Radiant mode. Okay, try that. I'll be right back. These are unit circle values. Now we're also going to practice going the other direction where I give you something in rectangular form. You have to use inverse tangent and Pythagorean theorem to get to the polar form. But with polar form, we can create more variations that hit the same point. Now we kind of did this yesterday with degree mode, but to do it in terms of radians it's a little bit more challenging because these numbers are not as familiar to us. So as a reminder, I have it on the board. I'm also going to put it up here. So as a reminder, let me kind of go through a few things here. We know to go from 0 to 90 to 180 to 270, 360 in degrees. That's very familiar. We know just by looking at degree measure, whether it's going to land in the first, second, third, or fourth quadrant, right? But in terms of radians, it's not as familiar. So we know that between 0 and pi over 2 is first quadrant.
From pi over 2 to pi is second quadrant. Pi to 3 pi over 2 is third quadrant. And 3 pi over 2 is the 2 pi is fourth quadrant. Now the decimal versions of pi over 2, pi, 3 pi over 2, and 2 pi are 1.57 for pi over 2, 3.14 for pi, maybe that feels more recognizable. 4.71 for 3 pi over 2, and 2 pi is 6.28. So when we get a radian measure that is landing between those decimal values, we know which quadrant we're living in. Okay. Rather than adding and subtracting 360 to get to a measure that we want to look for, coterminal angle, we're going to add and subtract 2 pi to make sure that we land between negative 6.28 and 6.28. I'll leave this on the board here. So, and also, you'll get your calculator on the test. So if you're unsure about these decimal values, you just plug them in and get decimal approximations without having to memorize them. Okay, so for each point given in rectangular coordinates, find 4 unique polar coordinates between negative 2 pi and 2 pi. So therefore, between negative 6.28 and 6.28. We know we can get to the radius by doing Pythagorean theorem. We'll leave it in exact form. 4 plus 25 is 29. Inverse tangent to get to our radian measure. Make sure you're in radian mode. Now, which quadrant is this going to be in? Quadrant, right? 2 over down 5, quadrant 4. And typically, if we see degrees, we would know this is a reference angle, and we would subtract by what? By 360. But this is radians, so instead of subtract from 360, we're going to subtract from what? 2 pi. Yep. So we just have to make that adjustment, right? So subtract 6.28 minus 1.19. I know we're a lot more comfortable if we see theta being like 304 degrees or 330 degrees. We know that that's definitely the fourth quadrant, but we just have to understand how to make that adjustment and understand that is the fourth quadrant in terms of radians because it's between 4.71 and 6.28. So that is a theta and radian measure. So we want to create 4 order pairs in this form. And let me just create what I think, just to have some visual, right? We know that our point A is 2 units to the right, 5 units down. It's going to go along this line here. I think the easiest one is root 29, comma, 5.093. Now we can also create
a co-terminal angle of this also in the fourth quadrant by subtracting what? Because we want to land between -6.2a and 6.2a, so we can subtract what? Subtract, let's say we want to go back all the way around to the fourth quadrant again, to pi. Okay, so yes, but we are going to subtract pi to get to this other angle here. But right now, I just want to get all the fourth quadrants taken care of. So if I do 5.093 minus 2 pi, I get negative 1.190. Right. I know it's a lot more comfortable if we saw like 300 degrees and then we made it a negative 60 degrees. Right. But it's the same idea, right? Instead of subtracting 360 degrees, we're subtracting 2 pi. We're still in the fourth quadrant. So we're still walking out towards that fourth quadrant. Now, going back to 5.093, how can I get something that's in the second quadrant that I can use along this line? Subtract what? Pi, yep, subtract pi. That will take me back to that second quadrant, right? It'll take 180 degrees in the other direction. So 5.093 minus pi, that's going to give me 1.951. But this is the second quadrant, so I don't want to walk towards second quadrant. I want to walk away from second quadrant. So what's my R going to be? Yeah. So if we're in the second quadrant, let's create a coterminal angle that is also second quadrant. So I can take this and subtract what? Yes, subtract 2 pi. Yeah, subtract 2 pi. Right, I want a negative version of this. This is also a second quadrant. I want to walk away from the second quadrant to land in the fourth quadrant at point A. So again, negative root 29. The same process just feels more unfamiliar because these radian measures don't jump out at us, right? If we see a degree measure, we instantly know which quadrant we're in, but we just have to now kind of get used to these. Okay, try number 4. I'll work alongside you guys as you guys try it. Okay, first things first, which quadrant are we going to be in? Quadrant 3. Okay, so let's keep that in mind here. So I have two order pairs from the perspective of the third quadrant. And I also have two order pairs from the perspective of the first quadrant. The third quadrant measures are just coterminal angles. The first quadrant measures radian measures of just coterminal angles as well. One more thing I wanted to go over is distance formula. Okay, page 6. Now, distance formula between 2 points on the coordinate plane or Cartesian plane, we just take our order pairs and we do x2 minus x1 squared plus y2 minus y1 squared. If we want to find the distance using order pairs where your order pairs are r and theta, it has a similar form, but there's just a little bit more involvement. We got to do r1 plus r2 squared. We take our radius, square it, minus 2 r1 r2 cosine theta 2 minus theta. A little more involved, but it kind of has a similar format. We're still relying on both the r values and both the theta values to get that distance. Okay, so we're just going to practice that formula with the problem below. Find the distance between the 2 points, -3 pi over 3 and 5, -11 pi over 6. I'll just go ahead and name them. This is R1 theta 1, R2 theta 2, and we're just going to insert them into the formula above. So 3 squared plus 5 squared minus parentheses 2 times theta 3 times 5 cosine of -11 pi over 6 minus pi over 3. Make sure, what mode should we be in here? Radiant mode, yeah, we don't see, right? So once I identified which one is R1 theta 1, R2 theta 2, I'm just inserting them into the formula. Okay. Now, in your calculator, I would suggest that you put another set of parentheses around the two R1, R2 cosine theta 2 minus theta 1, just so that it's all together. Yeah, so practice entering that in. We should all arrive at the same decimal value. Okay, the last example on page 6, same process. The only adjustment we have to make is what? Put the calculator in degree mode, yeah. But same process. I'll call the first point R1 theta 1. I'll call the second point R2 theta 2 and put it into the same formula.
Oh, right.
Yeah.
Right, your classwork. Page 7. It's a few problems, 1, 3, 5, 13, 15, 5 problems.
So you didn't grab anything in the last season?
So for 1 through 5, you're going to use x cosine theta, r sine theta. For 13, 15, you'll use inverse tangent and Pythagorean theorem. You just have to adjust to the radians and knowing which quadrant you're in. Okay, go ahead and circle those problems, 1, 3, 5, 13, and 15. I gave exact values, but decimals are fine as well.
So for degree, space perspective degree.
That's right, yeah. So depending on what's given to you, if somebody's given terms for radians, you gotta put it in radian mode. If somebody's given terms of degrees, put it in degree. Yeah, that's the one. Okay, let me know if you're having trouble understanding where those decimals are coming from.
Like 0.96, couldn't you add or subtract pi, because you'd still be within like the range?
Well, you either adding or subtracting 2 pi. But they said that the problem says that make sure that your polar coordinates are between -2 pi and 2 pi. So if we're already positive and we're adding 2 pi, we're gonna be outside of the range.
We're trying to make the radius negative, so you'd only add pi, so it's like, go like a semicircle. You know what I'm saying?
For which problem?
Like for 13, like
Yeah.
if you went to like negative root of 139, what did you add? When you add a subtract pi from 0.96?
So this is first quadrant, right? So if I want to create another version of first quadrant, I can subtract 2 pi. Because -5.23 is also the first quadrant.
Then for the next one, you make it like negative root of.
Because I want to land in the third quadrant. So I can go in the opposite direction. So to get from first to third quadrant, I'm gonna add pi. Add pi will get me completely going in the opposite direction. Yeah. And keep working on this. You guys get your phones in a few minutes.
It's just gonna be everything that's been instructed.
That's right. Just yesterday and today. I will do a review on Wednesday.
It was, so let's.
You're always gonna get 2 positive radius, 2 negative radius. And then exactly, you're gonna get 2 positive radian measures and 2 negative radian measures.
Thank you.
Yeah.
We're just finished off. I would also. Just turn my sock off. It hurts. The Abe's worksheet. John. Oh, I'm so sorry. And I'll just do the worksheet on my own. So it's that, you know, I got that. That's not.
Oh. No, oh, it's kind of goes, where it's like full of box and things stuff.
No, I don't need it. I'm just following the.
It can be a burden with facial media.
I'll do the first.
Hey guys, go ahead, you go ahead and get your phones.
Yeah. You do the last four seconds. This page? I'm gonna start with this. Yeah. Yeah.
Are we doing conditioning? You have. Well, I think I got it.
I'm gonna do my own. No, sorry. If this is the first time, I don't feel like I'm right down.
I don't know. If we're gonna do
It's the first.
So I practically a
No,
lot.
I know, try to like, even if you get it done like on the 15th, you see something like 10 p.m., you know.
No, yeah. Okay.
Yeah, for sure.
I also wanted.
Get it done for work.
Show me right now. What? Show me first part. What?
Yeah.
All of this is. It's actually crazy. It's actually. I think checked out his number.
This is the good one. The only good one is this one.
No, there's two good ones.
This one has no skips. Yes, I'll.
The other,
I like the other one too.
no recognition.
No recognition. It's really pretty.
There's no recognition on it. Not the album, but the song.
Yeah. No, and good. Like, no, only in that, only in that.
No one's ever heard of it.
No way.
What?
Dude, yeah.
So they got.
Oh, yeah. And then. And the game.